Hi, this is Jacob Romack.
This is Ryan Pulich.
I'm Austin House,
And I'm Joe Haas. We are team number 1.
otherwise known as
JAR.
We are here today to present our pedestrian safety solution. After our thorough design process, we decided to implement rumble strips on the inside corner of intersections. Purdue has a large campus, which means walking to class can take a long time. Every day, over 40,000 students must travel to and from class.
The Purdue campus consists of roads with intersections, bike paths, and many sidewalks. These reserved spaces help cars, boosted boards, bikes, and pedestrians all reach their destination faster. However, at these intersections, pathways for transportation overlap and accidents occur every day. Common solutions already exist that aim to minimize accidents between cars and pedestrians, such as illuminated crosswalk signs, stoplights, and tactical paving to help blind pedestrians. Even with these safety features, accidents still occur. Campus Safety Committee expresses concern for traveler safety and presents the need for intersections that improve the safety of people moving around campus. The Campus Safety Committee has tasked us with collecting data and using that data with analytical. The Campus Safety Committee has tasked us with collecting data and using that data with analytical, evidence-based reasoning to propose an idea to increase mobile safety by decreasing the number and severity of accidents. Also, the equipment will be used outside, which means that everything will have to be designed to be weatherproof, which will also increase the price. Our solutions offer different amounts of effectiveness. We found that the more money we spend on these solutions, the more effective they were.
So the main criteria for this project is that, first and foremost, it must be economically viable for the university. It also must effectively increase the safety of transportation on the Purdue campus, and the solution must aid in interaction between the following: cars, bikers, and walkers. It also must not create any dangers for pedestrians, and the solution should not damage the environment and endanger wildlife. Additionally, the solution should be easily maintained over time. So after extensive research on pedestrian traffic, the first thing that we did was brainstorm how to increase transportation safety on campus. We also considered how the direct users and stakeholders would be impacted by the ideas that we came up with. We found background info and watched intersections and traffic to learn more about how the transportation system could be improved by the ideas we came up with.
For example, wait walk signs are good at discouraging people from crossing the street when they aren't supposed to, but in order for this to happen, the pedestrian has to look directly at the sign. One way to improve this would be to make the signs bigger and brighter. To narrow down our solutions, we measured the viability of each solution and chose the top 3.
This prototype shows how we'd position these on right-hand turns. Cars will roll over them and create noise for the pedestrians to notice, and it will make it uncomfortable for cars to take these turns when too close to the sidewalk. Hopefully this will make drivers more focused on pedestrians and pedestrians more focused on cars. As demonstrated from the model above, we'd implement a scuff strip along the edges of bike paths so that oblivious pedestrians who cross into a bike lane scuff their feet. This will make them pay attention to their surroundings. This is an example of an interactive LCD display system. The display will display cool facts and information so that pedestrians are preoccupied while at crosswalks in hopes of deterring them from jaywalking. We believe this will help reduce jaywalking since the second leading cause of jaywalking, according to our survey results, was boredom.
In the process of selecting the best solutions, one piece of feedback that we got was to change the projector idea to a screen attached to a light post. In the process of selecting the best solutions, one piece of feedback that we got was to change the projector idea to a screen attached to a light post. Another thing suggested was to make the shape of the scuff strip more rounded, with a wider base, because having a sharper strip will increase the chance of tripping for pedestrians.
After reviewing our constraints and criteria,
we constructed a weighted decision matrix. From this, we concluded that the rumble strips on the inside corners of intersections would be the best solution. It fit the criteria of having the least maintenance, decreasing injury, is inexpensive, and the most aesthetic. We weighted the maintenance and decreasing injury as the most important because these relate most to the goal of the project and increase the overall safety of the traffic. These expense and aesthetics were assigned a 5 score because Purdue has plenty of money to solve problems and all of our solutions will fit into the Purdue environment well. From our data, rumble strips have the largest value of 43.75. Rumble strips will be the best solution to meet their criteria. When Elon Musk's indestructible electric Cybertruck hits the road,
A potential method of keeping pedestrians safe would be by using our rumble strip design. In this clip, you can see an example of how the model would work and how the car would travel across said strips. During our testing of the rumble strips, we noticed that they mainly produce an auditory alert. Because of this, in the situation where a pedestrian was hearing headphones, they might not be alerted. During our testing of the rumble strips, we noticed that they mainly produce an auditory alert. Because of this, in the situation where a pedestrian was wearing headphones, or they might be auditorily impaired, they may not be alerted by the noise of the rumble strips and won't change their path to keep themselves safe. Considering this, we decided to add a visual element as well by adding a motion sensor that is placed within the rumble strips. This is connected to the wait walk sign at the other end of the street, which will light up and alert the pedestrian that there is a car behind them. The Campus Safety Committee expresses concern for traveler safety and presents the need for intersections that improve safety for people moving around campus. In conclusion, we did research of the problem and client, conducted surveys and observed hazardous intersections, brainstormed ideas in an organized fashion, and narrowed down our team's ideas. From this, we found rumble strips to be the most effective solution to decrease pedestrian accidents. Our solutions are designed to achieve this goal with efficiency while being cost-effective. They will reduce the number of accidents and will result in a great improvement in campus safety, which will meet and exceed the Campus Safety Committee's goal.